Hello everyone, I'm Dr. Sayeedakhanum Pathan working at VJEC as an assistant professor. Today I'll be dealing with relational algebra concept. Relational algebra is a procedural query language which takes a relation as an input and generates a relation as an output. If we have to work with relational algebra concept, then we must know about the basic operators present in relational algebra. See here I have given a relational algebra operators which is been divided into two main categories. First one is basic operators, second one is derived or extended operators. Under basic operators, there are again two types, unary operators and binary operators. Under unary operators, we'll be going to see projection operator, selection operator, and third one is rename. Under binary operators, we'll be looking around union operator, cross product, minus or set difference operator. Whereas under the category of derived operators, we'll be having three different kinds. One is join operator, division, and intersection. We'll be seeing all the operators one by one. Let us start with the selection operator. Selection operator works based on the rows of a given relation. One thing I want to be clear with. Before we learn or before we write SQL queries, we should be pro in relational algebra. Relational algebra teaches how exactly we can write SQL queries. So see, first operator, that is selection operator. Selection operator we can represent with a notation called this sigma symbol. How exactly it works is, so I can write here, the right side of my this one slide, you are able to see two tables. One is student table, the other one is result table. In student table, we are having roll number, name, age, and department as the four columns. Under that, 4 rows are there. The second table, that is result table, there you are having roll number, name, age, and the department. There also we are having 2 records. Now imagine a query or else a question where they're asking you to write a relational algebraic query to extract rows of your student table where student age must be less than 20. Then you are supposed to use this selection operator in this way. Select age greater than 20 and name of the table is student. I think you're able to differentiate this. Selection operator works row wise. Selection operator works row wise. Wherever see 19 is there, 21 is there, 22 is there, 20 is there. What is the condition? Age must be greater than 20. Such rows we are having two. One is 21 and 22. With the help of selection operator, we are applying a condition on entire row. So these two rows will be my result for this given selection operator. With the help of selection operator, I'll be clear here. With the help of selection operator, you can extract the complete row of a given relation. That is my first operator in relational algebra, that belongs to a unary operator. Few important points under this selection operator is, with the help of selection operator, you can make use of AND operator, OR operator, NOT operator, and all the relational operators such as equal to, not equal to, greater than, less than. These are all operators. You can make use of these operators additional to your selection operator. Second, selection operator selects the required tuples according to the selection condition. The third condition or third important point is, what is the nature of the selection operator is, it is a commutative in nature. That means, see I have written select A and B. A and B, this R is nothing but relation name, that is equals to selection of B and A. Here I wrote A and B, here I wrote B and A, both are same. Or if at all I'll be writing select some condition B, inside the bracket I'll be writing select A, inside the bracket I'll be writing relation A. These brackets doesn't matter, either you can write A first or else B first. Both cases are same only. This is applicable with selection operator only. Next, fourth important point is degree of the relation from a selection operation is same as the degree of the input relation. Why? Because see here in my previous example, roll number, name, age and department were the 4 columns. You look at the resultant table, there also the column names are same. Whatever number of column headings you had in your first table, the same number of columns you will be getting under your resultant table. That says that degree of your original relation is same as the degree of your resultant table. Degree is not going to change in selection operator, whereas cardinality gets changed. What do you mean by cardinality? Total number of rows is nothing but cardinality. See here, 4 rows were there in your original table. 4 rows were there. Whereas in the resultant table, you are having only 2. So that means degree remains the same, but cardinality gets changed. The number of rows returned by a selection operation is obviously less than or equal to the number of rows in the table, or else we call it as cardinality. I hope the selection operator is clear with respect to this relational algebra. Now, we'll see few examples with the help of this selection operator. Assume there is a schema or else a relation student where roll number is my first column, name, age, department and marks. 4 columns are there. We'll just see how to write a relational algebraic query by using the selection operator. First one is extract all students whose age is greater than 20, greater than 21. How to write this? You first write the symbol for selection operator. Then below that you write down what is the condition. Age must be greater than 21. Age must be greater than 21. On which relation you want to apply this? What is the relation name? Student. Write down student. This is the result. This is the result for your first query. That is extract all students whose age is greater than 21. This is how you have to write. Second one. What is the question? Extract students who belong to CSC department. Extract student who belong to CSC department. Start writing this symbol, that is selection symbol. CSC. What is the department name? DEPT equal to what is CSE. Since it is a varchar data, you have to always make sure that this condition or whatever values you are writing, that must be under single quote. Inside the bracket, you write down name of your relation, student. This is how you are going to write relational algebraic query for the second one. How you are going to write the third one? Extract students who scored marks greater than or equal to, again the same symbol. What is the column heading? Marks. What is the condition? Marks greater than or equal to, greater than or equal to 80. Upon which relation you are applying? Student. Simple. This is how you are going to write the answer for your third one. The same way you can write for the other 2 queries. See, next slide will be seeing the results. Age is greater than 21 upon student, department is CSE, marks greater than or equal to 80. Answers for other 2 queries. You can refer it later also. Next, second unary operator under relational algebra is projection operator. It works upon our columns. Selection operator works horizontally. Projection operator works vertically. Now, what do you mean by that? You are going to extract the columns from your table. See the first one, heading. Projection operator, that is pi symbol, is a unary operator in relational algebra that performs a projection operation. It displays the columns of a relation or table based on the specified attributes. Now imagine a table called student, where ID, name, subject, age are the 4 attributes what we are having. How to write that? How to write a relational algebraic query by using projection operator? Symbol is pi. Down to this symbol will be mentioning the condition. Inside the bracket will be writing the table name, that is R here. Now imagine we want to display student ID for the given table student. Then how you are going to write? Pi ID. Why? Because you want to project only the ID part from which table? Student. What does this mean? You want to project ID column of your student. What if you want to project ID and name? ID, comma, name column from the student. Then you will be writing like this. What will be the output for this? Only the ID part of your table, that is 200, 300 and 400. This will be the output for this. How about this? Student comma name. Output for this will be ID and name. This way you can project with the help of your project operator. Some important points we'll see about this projection. Okay, before that we'll see few simple examples or few simple queries. Display only the names of all the students. What does this mean? Display only the names of the student. Schema or else relation is given here. Name column is there? Yeah, it is there. Simple. Write down this. What does they want? Name. Yeah, name column is there. Inside the bracket, you write down student. That's it. Second one, display roll number and name of all the students. Again, pi symbol, roll number, name, followed by student. The same way you can write down the remaining 1, 2, 3. Even I'll show the answers for all the queries. See, pi name student. Then project roll number comma name from the student. Project department name from the student. Project name, age, marks of a student. Like this way. Few important points. The degree of output relation means the number of columns present is equals to the number of attributes mentioned in the attribute list. Degree is nothing but what? Total number of columns present in any table or else relation. Projection operator automatically removes all the duplicates while projecting the output relation. This we will see going on further queries. Third, cardinality of a original relation and the output relation may or may not be same. Next, selection operator performs horizontal partitioning of a relation. Projection operation perform vertical partitioning. What do you mean by this? We had a table called student. Yes, there we had 4 columns. With the help of projection, we are dividing the table in this way, vertical division based on the columns. With the help of selection operator, we were doing horizontal selection or horizontal division based on the select condition. That's what the meaning of this selection operator and projection operator. Third one is rename operator. Rename operator can be displayed with the help of this row symbol. Why do we need this? To rename our old relation name. Syntax is row of new relation name. Inside the bracket, you will be writing old relation name. Here, relation is nothing but table, okay? See, row symbol, rename the relation student as S2 stud. Then how you are writing? Row, new name. What is the new name? Stud. Inside the bracket, STUDENT. This is how you are going to write. This is the symbol, you remember this. With the help of symbol only, you are going to write. Theory part, you need to remember. Symbol you have to apply while writing relational algebraic queries. This is the third operator, which comes under the category of unary operator. Now, comes to this binary operator. Under that, set theory operators. We are having 3 types: union operator, intersection operator, and the difference operator. Whenever you are applying this set theory operators on a given tables, you make sure that those relation or tables are union compatible or not. What do you mean by union compatible? Union compatible means same number of attributes or columns must be there in all the tables. If at all you are having 3 columns in your first table T1, then you must have 3 columns only in your second table if at all you want to apply any sort of this set operations. Second thing, The corresponding attribute must have the same data type or domain. Third one, attribute names doesn't make any sense. You can have any name for any attribute that don't make any this one, but the domain or the data type must be same. Whatever data type you are applying on your first table, the same data type must be there in your second table. The fourth point I forgot to mention here, the order in which the attributes are there in your first table, in the same order your columns must be there in the second table. We'll see with the help of an example what do you mean by union compatible and how it works. Look at here, there are two tables. Left side of your this one, relation R and relation S. Okay, in relation R, how many columns are there? 1, 2, 3. That is ID, name and subject. Okay, ID is of type numeric, name is of type varchar, subject also of type varchar. Okay, second relation, that is yes, there we are having again 3 columns. A first condition for union compatible is matched, that is total number of columns present in S is equals to total number of columns present in R. That is our first condition. Second, data type of the corresponding columns must be same. Yes, see, in relation R, data type of ID is numeric. Here in relation S also, data type of ID is numeric. Here it is varchar type, here also varchar. Third one is also varchar and varchar. And also the fourth one, that is order of column headings, order of attributes in my first column is matching with the order of my second table. ID is first, next name, subject. Here also ID is first, name and subject. But one thing they told you, like whatever column heading name you want to give, you can give, but the data type must be same. But for the simplicity purpose or for your understanding purpose, I have taken the same names. Even you can write here ID, here you can write roll number, no problem. But make sure that the data type must be same. Here name you have written, here you can write yes name, that is also okay. Here you can write course also, no problem. Name doesn't matter, but the data type matters. Now comes to our actual topic, that is union operator. How union works here. Union symbol is U, that we already knows. How to write this union operator in relational algebra? R union S. R stands for your first table, S stands for your second table. In between you will be writing union. When do you use union? Whenever you want to merge two tables. Whenever you want to use, merge two tables, you'll be using this union operator. See, in R union S, duplicates are automatically removed. Duplicates are automatically removed. Before this, you see this sentence, R union S is the set of all tuples belonging to either R or yes or both. Whenever you want to join two tables, either by applying a condition on R or yes or both. Next, in R union yes, duplicates are automatically removed. How to check that? See the right side of your screen. You have applied R union yes and you are going to display a result. Under ID of my R, I'll be having 100, 200 and 300. Under ID column of my yes, I'm having 100 and 400. When you are seeing this resultant table, 100, 200, 300 and 400 are there. Only 4 rows are there, whereas in my original table I had 5. Why I'm getting only the 4 rows? Why? Because as rule says that union operator automatically deletes the duplicate row from the result. Which one is the duplicate row? This 100. 100 is there in my first table also, 100 is there in my second table also. So automatically it is going to remove one row, and in the final result it is going to show all the distinct rows present in my table 1 and table 2. This is how union works. Intersection symbol is this reverse U symbol. When we are going to apply this intersection, R union S is the set of all tuples belonging to both R and S. In previous one, either yes or yes, either R or yes or both. Whereas here, we are going to display tuples which belongs to both R and S. Common columns or common data present in my table 1 and table 2. That will be the output for my R intersection yes. See here also duplicates are automatically removed. Look at your first table. where I'll be having 3 rows, 100, 200 and 300. Look at your second table where you are having 100 and 400. Which is the common row between this and this? The first row, that is 100, Ankit and English. That will be your output for the R intersection. Yes. Third one, that is minus operator. How minus operator works? Again, it has to be union compatible. That all things we knows. What do you mean by union compatible? How it works basically is, whenever you're writing R minus S, is a set of all tuples belonging to R but not to S. But not to S. Then the output 100, 200 and 300 is there. 100, 200 and 300 is there. Here 100 and 400 is there. Which is the common row present between this and this? That is the first row, that is 100, Ankit and English. So other than this 100, the remaining 200 and 300 rows will be my output for R minus S. In simple way, the common rows present between the first table and the second table will be eliminated, and the remaining rows from your first table will be the result for R minus S. I hope you understood. Under derived operators, the very first operator is cross product. What do you mean by cross product or Cartesian product? The cross product, it is a binary operator that combines every tuple of one relation with every tuple of another relation. Here tuple is nothing but record or else rows. Okay. If we have a relation R which is having m number of tuples. Imagine you are having a relation called R which is having m tuples, and a relation S which is having n number of tuples. Then your resultant table R into S will be having m into n number of tuples. We'll go back to this, or else see this. According to this point, m into n. First table is student table, second one is course table. In student table, how many rows are there? 2. That is m equal to 2. In course table, how many rows are there? 2. That is n equal to 2. According to the definition of cross product, they are telling like, if at all you are applying R into S cross product, then in your resultant table, you will be getting m into n number of rows. That is 2 into 2. That is 4. Yes or no? They are talking about rows, not about the columns. So in my first table, 2 are there, 2 2s are 4. See at the right side, 1, 2, 3, 4. You are getting 4. How did you got this? You apply the basic concept of matrix multiplication. Here, first row will be multiplied with the first row of your second table. That is 1 Alice C1 DBMS. Okay, again 1 Alice, multiply this with the second row of your second table, 1 Alice C2 OS. Done. Second, 2 Bob C1 and DBMS of your first row. Next, second row of your first table, 2 Bob, the second row, that is C2 and OS. This is how you are going to get the cross product result. This formula you remember, that is m into n. So directly you can say in the resultant table how many rows or how many tuples you are going to expect. Okay, this is what about this point. Now, operates on two relations. No union compatibility is required for this cross product. Remember this point, okay? The resulting relation contains all the attributes from both the relations. Since we are not bothered about union compatibility, then obviously the resulting relation contains all the attributes from both the relation. This what we have seen here. SID and name belongs to my first table, CID and course belongs to my second table. All the attributes will be there in my relational or resultant table. This is how the Cartesian product works. Comes to this join operation, which is a very important topic in relational algebra, in relational calculus, and even in SQL. If you know how to write or how join works in relational algebra, then it will be very easy to apply these join operations in SQL also. In relational algebra, join combines tuples from two relations based on a condition. See here again, student table, department table, same tables or same relations we are referring since we have started that relational algebra topic, that is student table and department table. Under student table, we have 3 columns, SID, name and DID. Department table, we are having DID and DName. If at all you want to join these two tables to extract some sort of details out of these two tables, then we are going to apply this join concept. When you can apply join concept? When you have a common column between table 1 and table 2. That is the very basic condition. If at all you want to work with join concept, you need at least one common column between table 1 and table 2. In relational algebra, the first join is conditional join. We can refer that as theta join also. How to represent that? R is my first relation, S is my first relation. This symbol I'll be using. R, this indicates join symbol in relational algebra, okay? Here I'll be mentioning the condition. Theta, in place of theta, I'll be mentioning the condition. On what condition I want to join R and S. That is why sometimes we call it as theta join also. So see at the right side, you are having two tables, employee table and department table. Under employee, you are having employee ID, name and DID. Here you are having DID and DNAME. DID and DNAME. You can write a query or you can apply a conditional join saying that you want to perform a join operation between employee, join, department based on department DID is equals to employee.did. What does this mean? You want to join these two tables based on this condition. What is the condition? DID present in my department table must be equal to DID present in my employee table. If these two condition, if this condition matches, then in that case only I want to join these two tables. If at all, if I'm not applying any condition here, then automatically it will be working as a cross product where total number of rows will be 2 to the 4. M into n is equals to, that will be my cross product. So join is nothing but cross product plus some condition. If you skip this condition part, then join is equals to cross product. So that thing you remember. Whenever you are applying some join, there must be some condition and there must be some common column between first table and second table. See an example for conditional join. Previously I wrote this only. Employee table, perform join operation based on this condition. DID value of my employee table must be equal to DID value of my department table. Based on this condition only, you perform join operation. That's what you are telling to your system based on this relational algebraic query. So this will be the output where I'll be getting employee.did is 10. Yeah, department DID is also 10. So I'll be getting first row as my output. Second time, here also 20, here also 20. Then second row I'll be getting. So this will be my result for this particular join operation under theta join or else conditional join. Second type is equi-join. Equi-join name itself suggests while performing or while assigning condition here, you're always going to use equal symbol only. Equal symbol only. Whereas in other join operation, whereas in conditional join or theta join, other than equal to symbol, you can make use of any sort of symbol, equal, less than, equal to, greater than, not equal to. Any sort of operators you can make use, whereas in equi-join, you are allowed to use only the equal symbol. The same example can be depicted for both equi-join and for conditional join. Why? Because in conditional join, there is no such rule that you are allowed to use only greater than symbol or less than symbol or not equal to symbol, nothing like that. You can make use of any operator while performing or while assigning this condition, whereas in equi-join, there is a condition that you're supposed to use only the equal to symbol. The other rest of the things are same. Here 2 times this column will be displayed. The other columns of your first table and the second table will be displayed whenever you're satisfying this condition. Third one is natural join. This is the mostly used join in our relational algebra, even in SQL. In relational, in natural join, the benefits are like, see here, yes, they wrote. They haven't mentioned any condition. Since it is a natural join, there is a condition that whenever you are applying or whenever you want to apply natural join on any 2 columns, then there must be a common column. There must be a common column with same heading, DID and DID. Then automatically it will apply equi-join concept on these two common headings and it will perform the join operation. I hope have given clarity on this. Natural join is nothing but we are not going to write condition explicitly, but make sure that whenever you are using two tables, the common column heading must be same. In that case, this natural join automatically try to equate those common columns and project the result for your natural join query. Now see here, previous example only. Yes, student and department is there. In our equi-join and in conditional join, we are happen to see employee.did and department.did. Two times these columns are being represented or displayed for this conditional join and under equi-join also. Whereas in natural join, the plus point of natural join is it is not going to display the did separately for employee and separately for department. It is going to display the did column only once. There are two benefits. First one is no need to mention the condition explicitly. Based on the common column heading, it is automatically tried to equate. Second thing is, in the resultant table also, it is not going to display the common columns two times. It is going to display only once. Okay. Next comes to division operator. Division operator, how it works? Look at this syntax. We are going with the concept of two tables, R and S. Imagine in R we have only two columns, that is X and Y, and in S we have only one column. Can we say S is a subset of R? Yes. Why? Because we have Y column in my S, I have Y column in R. Yes or no? Yes. Now how it works? It is a binary operator in relational algebra used to find tuples in one relation that are associated with all tuples of another relation. It is mainly used to answer queries containing all. Whenever you find every or all keyword in the questions, then you blindly go for this division operator. Why? Because with the help of division operator, we are trying to find tuples in one relation that are associated with all tuples of another relation. All tuples of another relation. In that scenario, we'll be using this division operator. R and S are two relation. Attributes of S must be a subset of attributes R. The result contains attributes of R that are not present in S. The result of this one will be R of X. It is going to subtract Y from R. The remaining elements of R will be your result. This is how division operator works. Now see this simple example. We have a two table. One is student course table. Student column is there, course column is there. Second table, that is table 2. This is your table 1. Okay. What your table 2 says, these are the required courses or mandatory courses. What are this? This is simple student course table. Now there is a question. Find students who have taken all required courses. You need to find out the student names who has enrolled all the required courses. How to write that? You will be using division operator. Student course divided by required courses. Divide by required courses. How many required courses are there? DBMS, Python, Java. We'll start with A. Student A has enrolled in DBMS, student A enrolled in Python, student A enrolled in Java. That means A is one among our result. Second, we'll check for B. B has enrolled in DBMS, B has enrolled in Python, but B has not enrolled in Java. That means B doesn't comes under a resultant thing. C enrolled in DBMS, C enrolled in Python, C enrolled in Java. That means A and C are our result. In such cases, we'll be using division operator. Now overall, now we have seen all the operators present in relational algebra. We'll see some basic queries which combines all these operators. Okay. Look at this three schemas: sailors, reserves and boats. These are three tables what we have. Upon this, we'll see this query. Find the names of sailors who have reserved boat number 103. Find the names of sailors. What output they want to display? Names. They want to display only the names. This column they are interested. But what is the condition they want to apply us? sailors who have reserved boat number 103. Then we have to check boat number, that is BID, is present in which table. Basically we have three tables. One is sailors table, reserves table, and boats table. With the help of first question, they want us to display sailor's name. That sailor's name is present in my sailors table, but boat number table, boat number, that detail present in my reserves table. So I am in need of two tables, sailors and reserves. What they have done, see, this condition BID equal to 103, BID equal to 103, this condition I have to apply on reserves table. Why? Because BID column is present in my reserves table and yes name column present in my sailors table. There is a common column called SID which is present in my sailors table and SID is present in my boats table. So easily I can apply natural join between sailors and reserves. Yes or no? But what is the condition I have to apply on reserves? Wherever BID equal to, wherever BID is equals to 103, such rows I have to extract from the reserves table. Then upon those rows I have to apply join operation. From that resultant table I have to project only the yes name from my sailors table. That's what they have written here. See, first what they have done, they have selected rows from the reserves table wherever BID equal to 103. BID equal to 103, they have selected the rows. Then upon that intermediate table they have applied join operation with sailors table. From there finally they are going to project. So we'll see 103, BID equal to 103, 103, then 103. These are the three rows we'll be getting. What are the SIDs of those? 22, 31, 74. Where is 22, 31, 74? What are the names? Dustin, Luber, and the Horatio. This will be the result for my first query. Similarly, second question. Find the names of sailors who have reserved red boat. Red boat. Ultimately, they want us to display the yes name only. But to display those yes name, there are some following conditions. What is that? Red boat. They are telling us to extract the names of sailors based on the color of boat. Based on the color of boat. Where is that color column present? Color column present in boats table. If at all I want to extract the yes name, I have to join these two tables first based on the SID. If at all I want to get the color of boat, I have to join these two tables based on the common column BID. So totally I am in need of three tables. So how to join that? First, apply selection operator based on this color column upon this boats. We'll be getting two rows, that is these two. Take out this. Again you apply join operation between these two tables. Reserves table, reserves table, reserves table and boats table with this condition called color is equals to red. Okay. Upon this whole table you apply join operation with sailors. Upon this whole you project this one. See, the same way they have done. What they have done? They have extracted the rows wherever color is equals to red from the boats. We'll be getting some intermediate result. To that intermediate result, you apply join operation with reserves table based on the common column BID. Based on the common column BID. Okay. We'll be getting some second intermediate result. To that you apply join operation with sailors table. Why do you need sailors table? Why? Because they are interested in yes name, not in SID. If they would have interested in SID, then from here only we would have projected the SID. Since they are interested in yes name, we are in need of the sailors table only. So upon this final table, try to use project table to project yes name from your complete join table. So this will be the result. What will be the result for that? We'll just check it. Red and red. What are the BIDs? 102, 104. 102, 104, 102, 104, 102. See how many are there? 102, how many times? 102, 22. This 22. Then 31, 31, 64. 22, 31 and 64. 22, 64 and 31 will be our result. So if any duplicate values are there, automatically it will eliminate. Projection operator will not keep any duplicate values. Automatically it will remove or eliminate the duplicate values. So third one, find the color of boards reserved by Luber. Find the color of boards reserved by Luber. Color, what they want to project? The final output, always you remember, whatever your final output will be there, that you need to write under this projection operation. Conditions, whatever conditions are there, that you have to mention under selection operator. Yes num equal to Luber, under Saylor table it is there, so you'll be writing it like this. Perform join operation with reserves table based on the common column, that is SID. Then finally, to extract the color, you are in need of boards table. With the help of BID, common column, you'll be applying join operation. Then this will be your final result. Next, fourth query. Find the names of sailors who have reserved at least one boat. At least one boat. So BID details are there in reserves table, and there is an SID column which is present both in sailors and reserves. So with the help of reserves table and sailors table, you are able to display all the details. Then find the names of sailors who have reserved a red or a green boat. A red or a green boat. Since there is a keyword called or, so we can make use of union operator here. Union operator. It says that either this or this. If at all or keyword is there, we can make use of union operator. If at all and keyword is there, we can make use of intersection operator. See what they have done. Names of sailors. Again, they are interested to display names of sailors. First, what they have done, color is equals to red. Such boats, such rows they have selected from the boat table based on this selection operator where they have written the condition as red. They have selected those. They applied union operator based on the green boats. Color is equals to green from the boats table. Both they have extracted, both the rows. Then they applied union operator that they have stored under a temporary table, temp boats. Then with this temp boards, they applied join operation both with reserves and sailors. From there, they have projected the S name. This is how we can write relational algebraic queries. You can use Raghuram Krishnan textbook to get more expertise on this relational algebraic query. This is all about relational algebra. Thank you.